Now you can imagine how these data functions, people who have a little bit of knowledge of R, how they've gone to town in Spotfire, because having an interactive immersive graphics experience along with this R experience. So here's another one where someone's done a hex bin analysis. These are individual points, but if you put a grid of hexagons on top of this, is a well-known graphics technique for surfacing up the density, and you can see here there's high concentration here where you can't see anything from this cloud of points. Over here you've got a hex bin analysis to show this the hotspots in this analysis. So people have gone to town on this in the combination with the mapping. We do things like kriging, we do polygon points analysis. In the energy sector, this is very important to do this accurately on a map, as you might imagine. And there's a lot of different coordinate systems. There's a world global system, WGS. There's a North American system, NAD. These are different projections. And we've written some TERR data functions to transform those coordinates that allow you to bring in different source coordinate systems and add them directly on the same map. We're the only software on the planet that will allow you to do the routing charts that are in the magazine in the seat back pocket in front of you on the plane. We can layer those onto a map. We can do trade area analysis to look at drive time or drive distance from a store. This is very important in the retail sector to understand what customers you might have in the region of the store. Procter & Gamble does this, for example. Look at stores of Target, Kroger, that sort of thing. Understand within a 20-minute drive time how many babies are there, and they set targets for their retailers on how many diapers they should sell in those stores, for example. But we've got data functions for all those things. Points in polygon area analysis, route optimization, these sort of things. So also the map chart that I'm sort of showing you in combination with our predictive analytics can be applied to other non-geographic type maps. So we've done data functions to allow our high-tech manufacturing customers to look at their semiconductor wafer yield and find patterns in that through visual analytics. But the layout of the wafer, we've kind of figured out a quick way to do that through a data function. Here's that interactive polar chart where we wrote a piece of R script for creating a set of polygons that can then be interactively linked to the rest of the Spotfire graph chart. Here's an impedance analysis on a Smith plot where we register the scale of the Smith plot, and then with those layers that I showed you on our map chart, we can put individual observations on top of that to track impedance. Here's a refinery process, crude oil coming in the left, refined product coming out on the right. We've registered that image, and now we're doing an analytics on top of that image to show the reliability of different components of that process. Here's a helicopter where we're looking at maintenance and issues on the helicopter, where we've again registered an image, and now we're doing analytics on top of that. So it doesn't have to be geographic. The way our map chart is set up with those layers that I showed you, we can have layers that are coming from the R code, coming from an image that's been registered, coming from other sources that we can manage on the map chart. Very powerful. We acquired a company some years ago that was specialized in mapping and injected that into the product.
I was going to ask you if you wrote it yourself.
Yeah, well, we had a company called Mapperama, a French company that was specialized in this. We acquired them some years ago and put that into Spotfire, and now we've added it with the rest of our tool set to create this kind of on steroid mapping capability.
And not just mapping, but they actually they have a fully fledged geocoding service. So AC Nielsen, for example, does all of their geocoding via that service, and at some point we'll surface that inside of Spotfire as well.
Do you work with graduate business and engineering schools to get their students tuned into what the capabilities of your products are and how they can integrate that into the value that they bring to the workplace as the leadership of the future?
We've done a little bit of that, but to your point, we could do a lot better there, and we have some programs to kind of ramp that up going forward. So that's a good suggestion.
I'm curious on the helicopter one, or anything that has could be a truck. Can you do individual panels on each of the assets? In other words, if you've got 20 helicopters, each one has its own.
Yeah, it's no problem whatsoever. Yeah, these are all trellisable. All the things that you do in Spotfire, these are full Spotfire analyses that you can do all the filtering, marking, trellising, that sort of thing for sure.
Yeah, I think one of the things that really impressed me is the fact that when you generated the contour lines from the R routine, that came in as just another data table,
right,
which you just dragged and dropped right on top of everything. And then you could see the layers that pop it up to the top, and also the fine control over widths of lines and colors and things of that nature, sort of a couple
Yeah, thanks for that, Richard, because it is a blending of this powerful compute engine with the inbuilt capabilities you already have in the Spotfire product. That seamless transition, we own both sides of it, so we can really...
The combination that's the power, and you know, just to reflect back on something that Michael said earlier, no one else can do this. They're forbidden by GPL license, if you get my meaning, right? The R engine cannot be bundled into commercial software without making all of that commercial software free. You can do an arm's length connection, and almost everybody will say we have an R integration, but what they mean is we're going to ship our data out, make a calculation, and return a new column. That's it. We do parameters, whole tables, you know, column-oriented, you know, layers, graphics. So, yeah.
How did you take open source and commercialized it?
We wrote it from the ground up. In fact, I might have a slide here on this.
Oh, okay.
So it's not R as we know it. It's your version of R.
It's our version of the R engine that we've re-engineered.
I mean, just to be clear, right? I mean, it is the open source R language. Right. And we process that language with a commercial engine that is proprietary.
Right.
Which means it's CRAN compatible.
It's CRAN compatible.
So you can take the open source CRAN stuff and execute it on your proprietary engine.
That's right. And that proprietary engine is faster and better in almost every way, because the open source engine isn't really designed for commercialization. That's not a priority for that team.
That was a research
Now, how does that compare
project
with Revolutionary Analytics?
So Revolution R, they ship the open source engine. They are like the Red Hat for R.
Yeah, and they just stack things on top of it.
They've got a couple of things they stack on top of it. They do have a couple of packages, you know, Revo Scale and Revo Deploy that they add onto the open source. But they, you know, require you to kind of, you know, get the open source R component.
Honestly, you know, those packages are compatible with TERR. So you can take advantage of the Revolution expertise, and they're quite good, but in a better, more modern kind of core engine. So they really should be used together. You know.
They can be. Some of our manufacturing customers use both, but be clear that the core R distribution that they promote is open source. They just have two proprietary packages that run on the open source, whereas we have done the opposite. We've re-engineered the core into a proprietary engine that we've developed that we own.
So how does TERR handle memory constraint?
Well, TERR is optimized for memory compared to open source. That's one of the big things we did to get the performance improvement. Okay. So yeah, that's a big part of the engineering. Let me move on in the interest of time, but yeah, it's fascinating the way we've kind of managed to both have an engineering team on TERR to optimize a commercially owned and supported engine, but combined with the Spotfire side, we've got product management engineering focused together on those things jointly. So let's talk a little bit about, you know, this TERR engine is fabulous. We want to have all that capability I just showed you, but there's a lot of other engines out there besides R, right? So we want to embrace those as well. MatLab, for example, great engine. SAS, we mentioned NIME and LavaStorm that are out there. H2O for doing modern machine learning. SkyMine for doing modern deep learning. You know, Python. There's lots of engines out there. So we can, on the server side, you can call out to those and do the similar sorts of things that I showed you there. You can have data functions that call out to those engines rather than just the internal TERR engine. And on the server, this is interesting because we've got Spotfire here. We've got data on the server. When you point Spotfire at a data source, it introspects the tables, and you can say, I want these columns from this table, blah, 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 and we create a meta layer. It's called an information link. Now, Spotfire creates that link and saves it in the library, but from the TERR side of things, you can say, go down that information link that Spotfire's created, get the data from the data source, do some TERR analysis on the server, do all that server side, and bring the results back into Spotfire. So there's another point of deep integration there with the Spotfire data connector with the TERR engine. So we can read those you know, on the server side and do that sort of scalable big data analysis on the server. So I wanted to make sure you realize I did a client demo, but the same sort of thing will work on the server, and it works with other engines on the server.
It's the notable omission of Spark in your list.
Yeah, I could have had you know, MLive or something like that on there. I could put that in there. These are some
you can. Okay.
Yeah.
So
yeah, you can do that.
technically, or you?
I just didn't put it in there. So yeah, we can invoke those engines. Spark R is one angle we use on Spark, as well as ML Live.
Spark R,
Yeah, so we directly support Spark as an in-database data source. So you can use Spark as an engine to do just the basic visual analytics, where you're passing a query down and asking for aggregates back from a visual point of view. And then we have support, as Michael said, for Spark R, which allows us to push commands to the sort of statistical part of Spark.
Right.
But Spark as a whole is a fully supported external data source and engine for us, in addition to how we support the kind of stats that ride on top of it.
And we actually contributed to the Spark R project. Our engineering group on the TERR side put some code in there to facilitate TERR running through Spark R. Now, you just briefly on Spark, so H2O has a great Spark connection, sparkling water. SkyMind also has a great Python connection into Spark. And so we're kind of, in addition to those, what we just discussed, we're supporting R and Python and parallelized machine learning from SkyMind and H2O into the Spark environment. So yeah, these are just the popular ones that are out there right now in the Valley and other places. So this allows you then to do some, deep learning, for example, as a hot topic, especially with SkyMind and H2O. These guys have got great tools out there for doing that. But we can set up a Spotfire TERR data function for calling into SkyMind or H2O and run that in the same input-output data function paradigm that I just showed you. So here's an analysis one of our team did recently, looking at anomaly detection across a set of network components. When a network component has an issue, it writes an entry to a log file. We're able to read those in real time, create an anomaly detection model, and figure out when there's a significant issue before there's people get affected by it. So this is deep learning is a really interesting area for anomaly detection, fraud detection that we're embracing through this same data function construct that I showed you for Tibco R. And so we've just done a plethora of things. Us and our customers have done a lot of things around machine learning, boosting, random forest, deep learning, anomaly detection, customer analytics, simulation, genetic algorithms optimization. We've got a pretty healthy community site where people are creating the data functions and then sharing them for reuse in a Spotfire environment.
Now, the bugaboo here is that you generate an optimal model, contour lines, for instance, just like you did. But it's surprisingly often that that optimal model is worse than random guessing. Unless you have a rock, unless you do some validity testing on the models.
Right.
Okay.
Very good point. Very good point.
You can go.
So lower right-hand corner is an Rrsp analysis. So we have a template for that allows you to bring in a number of different machine learning models and do the Rrsp analysis and pick off the best one. So that's one of the templates that's available for that. I'm glad I put that screenshot on there. I had a choice of which 6 to choose.
It's got to be like when you drag the data table in. I mean, there should be some attribute attached to it. How valid is it?
Yeah.
Okay.
Yeah.
And unless you have associated with a rock curve, you don't know whether or not.
No, our job as a vendor is to make these tools available for our end users. We do education as well, but the data scientist needs to know that sort of thing. That's why you kind of need data scientists, because.
And we're, the very next section, we're going to be getting to streaming. And in the Streambase 10 environment, we have what we call an artifact management server, which is designed for, submitting, approving, versioning, and pushing out to production a variety of kinds of assets, including statistical models.
Okay.
So we've got support for a system that allows for governance of all of these different kinds of assets.
So this allows us to create these various analytic apps that have been so popular in our community for doing things like optimizing pricing, inventory, cross-sell, that sort of thing. And so let me jump into the second part of the demo here on trade fund analysis, where I'm going to show you some of those techniques. Now, with the trade fund analysis, what we want to do here is start off by looking at demand forecasting. It's a very common problem with our customers. I've got 7 distribution centers here in the big blue circles. And these purple triangles are the stores that I'm selling. I'm running a coffee company, and the brand promise is to get fresh coffee from these distribution centers out to these stores. Now I can, the green horizontal line here is the available inventory. If I right-click on this and do a forecast, you see the forecast just shows up. And this is a one-click operation powered by TERR, Tibco R, and I can see that in San Francisco, my forecast is above my inventory. So I've got an actual analysis of this that I'm going to do through a conversation. Brad mentioned we have this ability to do collaboration. So I'm going to drive this quickly through a conversation given time constraints, and here's the comment here. Say San Francisco, we're a bit light on supply here given our demand from San Francisco. But down in San Jose, they say, well, look, we might be able to help because it looks like we're projecting lower demand and we might have some excess inventory. Out in Oakland, they're saying, well, look, we're also going off the charts here. And I'm looking at this collaboration going on. I'm saying, well, gee, what's going on in Oakland? That looks awesome. I'm going to drill down into Oakland, and I can see that we've got, over this last 4 months, we've got a very high proportion of novelty coffee sales as a proportion. And I'm trying to figure out, well, if that's doing so well, wondering, why that is doing so well. What's been selling, in Oakland, and how can I reproduce that? So if I drill into Oakland, I can see that the last 4 months we've been running a promotion for an in-store coupon. So seasonally adjusted to the 4 months in the year earlier, I can see a really nice lift. In fact, this novelty flavor that I saw jumping as a proportion is also a 25% increase in sales. We've gotten some good sales lift in standard and cold brew as well. So let's learn from this in-store coupon campaign, and I'm wondering how is that comparing to our other promotions? Well, we've got another promotion running on a sample giveaway that doesn't look like it's doing so well, but the in-store coupon is doing well. So let me understand how I can take that in-store coupon and apply that somewhere else. In fact, Napa is jumping into the act here and saying, well, we don't have any promotion. What can we do in Napa? So, well, let's say for Napa, let's give you a little calculator here and say, if you were to get that 25% lift that we got in Oakland, what would that do for your business? Well, it would give a $800,000 return on a $46,000 campaign cost. That looks pretty healthy. But maybe we're not that optimistic. Maybe we do half of that. Well, still we've got a pretty healthy return at a pretty light cost. And so let's figure out how we might want to run that in-store coupon campaign, up in Napa. So you've got visibility into the forecast very simply. We've got this effect analysis that's an A/B test that we have in the product that allows you to do that testing. And now we can start to understand what we might want to do. So we've got Napa, we're going to run the new promotion. Oakland is doing very well. San Francisco is doing well. San Jose, maybe not so well. How do I fulfill the promise of my brand and get fresh coffee out to all of these stores to meet the projections that I've got here? So this is now a look at the routing. This is the geoanalytics part of the product, and I look at the various routes that I've got available. And I can now optimize the routes for the total driving distance. So I'm going to minimize the total driving distance. I've got a constraint on the analysis that says I can only run 50 trips per day per distribution center to keep the coffee fresh. So what is the optimal routing? So it seems like we're going to push a lot of the deliveries out from San Jose, but here's the other deliveries we need to make. We've minimized the total driving distance down to about 3,300 miles, and we've chosen the routes, from the distribution centers out to the facilities to minimize that function. So the optimization here is through an R function called LP solve, which is a linear programming construct. Again, it's just in a data function. So I can jump down into my data function. Here's my script here. It's using the LP solve. Here's the inputs, the outputs. It's got reference about it. So yeah, it's another example of how we can do a fairly sophisticated analysis in combination with our mapping and our Tibco R engine to address that problem. So in this quick analysis, I've shown you how we can do demand forecasting on the right-click button that's using the TERR engine. I've showed you how we can do A/B testing to do a trade promotion analysis. I've showed you how to do a what-if scenario to look at how I can apply promotion into a different region. And then I've done a route optimization to fulfill the demand in those various regions, all in a pretty simple dashboard. So that was the idea there. So all of those analyses that our customers want, we can configure up in a real-time TERR analysis. So